Welcome guys, hope you're doing fine, enjoying my videos. Sorry for the delay in making this video, but I brought up another challenge for you guys. So here are two sets of 4 questions, as you can see here. And this is the first question, or the first set. So here we have an isosceles triangle ABC, where AB is equal to AC. And then we have P is the reflection of B with respect to the circumcenter. So basically, PB is the diameter. And L, M, N are the feet of the perpendiculars from P to AB, AC, and BC. If the ratio LM is to MN is equal to half the ratio of the base B to the altitude A, given that the altitude is greater than the base, then answer the following. So we have two cases here. Well, not exactly cases, but we'll call them questions, because the second question is basically the model which comes up no matter what conditions you have. No matter what A value you have, or no matter what B value you have, as long as they satisfy this condition, then A will always be the same value. So you have to find the answers to these questions. And then we'll move on to the answer first, or the solutions, and then we'll go back to the second set of questions. So we're going to assume half the base to be the variable k, and circumradius is r, capital R, which is pretty often used to represent or denote the circumradius. So then we have r squared is equal to k squared plus a minus r whole square. Think about it. You can draw an isosceles triangle, and then you can, try to figure out at which point on the altitude or median does the circumcenter lies that it satisfies this Pythagoras equation. So basically from this you get r is equal to a squared plus k squared by 2a. And now you have PC. Now since PB is the diameter, any point on the circle forms 90 degrees with that segment, PB. So basically in this case we have angle PCB is 90 degrees because C is a point on the circle and PB is the diameter. And now this is just basically something you can just figure out on your own. This is pretty easy. You can draw the diagram if you want to make it look easier. Then simplifying this, we have 2 into a minus r, which gives you a squared minus k squared by a. Then moving on to the next point, we already know this since a and c are points on the circle and pb is the diameter. Then we have a coincides with L because we discussed that L was the perpendicular from P to AB, and that happens to be A in this case. And the same thing applies for C. C coincides with N also. So all we need is just AM is to MC. Now here, if you use a bit of trigonometry, then you will figure out how to do this pretty easily. So first, we know that BC is perpendicular to PC. So the angle ACB, or ABC, whatever it is, forms, if it forms, let's say, the angle theta, then the angle PCM forms 90 minus that angle. So because of that, we get PC sine angle ACB gives you the length of the foot of the perpendicular M to the point C. So basically that's what we're doing here. And then if you can see here, we just substitute the value of PC, which we've decided or derived before, and then we get this. Think about it. PC, if you put this in PC, then you get this, and then A cancel out, the A's cancel out here, then you just have a squared minus k squared by root a squared plus k squared. And now since we know the length of the entire line segment AC, which is root a squared plus k squared, obviously, So we just subtract it to find AM, and then you get 2k squared by root a squared plus k squared. Now what we need to find is the ratio between AM and MC. So that gives you 2k squared divided by a squared minus k squared. That is what is written here. And then given in the question was half the base, which is k, to a is the ratio which was supposed to be equal to this. So this is the equation we're supposed to solve, and then this gives you this equation. This is a quadratic equation in a squared or a k squared, but what we really want here is the ratio of a to k. So we basically just divide both sides by k squared, and this just remains as 0 because the only time you cannot divide by k squared on both sides is when k is 0, but of course it's not 0 because we're working with a non-degenerate triangle. So you just get a by k whole square minus 2a by k minus 1 is equal to 0, and that just gives you a by k is equal to root 2 plus 1. And then putting in b now, we just get a is equal to root 2 plus 1 by 2 into b. Now when r is equal to 1, when circumradius is 1, the formula which we had, a squared plus k squared by 2a for the circumradius is equal to 1, right? So now just substitute this ratio over here, and then you eventually get the value of k. Here it is. K is 1 by root 2. Then we have b is equal to 2 into k, which is root 2 in this case. And then we get b squared is equal to 2, which is what they asked, the square of the length of the base. Then we want to find the angle A, the vertical interior angle A. So that is basically 2 times BAS, where S is just going to be on the altitude, so it's just going to be half the angle A. So just find the tan value of BAS, which is going to be K by A, obviously. And then that is root 2 minus 1, basically the reciprocal of what we got here. You can multiply and see for yourself if they multiply to get 1 or not. Then what we do is just use the formula for tan 2 theta, which is 2 tan theta by 1 minus tan squared theta. Then if you notice here, you basically get 1. And tan of what is 1? That's where you get 45 degrees. So basically we get tan inverse of 1, which is 45 degrees, because we don't want it to be in, it can't be 135 degrees because that would be negative 1, like tan 135 is negative 1. And the only other instance when tan is positive is in the third quadrant, meaning they're between 180 degrees and 270 degrees. So that gives you the angle 315 degrees. But that is too much for a triangle. The sum is supposed to be 180 degrees, so you cannot let it go that far. Now since we've solved both these questions, let's go to the second set. This is pretty short, but very interesting. So 2 chords, AC and BD, intersect at a point P in the interior of a circle. So make sure it does not intersect on the circle or outside the circle, just in the interior. So if PA is 6, PB is 4, PC is 2, and PD is equal to 3, then answer the below. First of all, make sure the question follows the power of a point, which is basically these values in a certain order should be in proportion. So now since you have AC is 1 chord, PA into PC is supposed to be constant for any chord that passes through that specific point. So since BD and AC pass through the same point P, we get PA into PC is equal to PB into PD. That's basically what power of a point says. Now if the quadrilateral ABCD has integer side lengths, find its area. That's one question. And if it is tangential, then find its in radius. That's the second question. So first we start assuming CD is equal to X, and then PCD and PBA will be similar triangles, obviously, because one angle is two corresponding angles are vertically opposite, so they're equal, and then the other two sides are in the same ratio. Since we know their side lengths, we can just say that. And then that gives you AB is equal to 2x, because you'll realize that one triangle is actually 2 times the size of the other. So similarly, we take BC is equal to y, and this gives us AD is equal to 3 by 2y due to the same similarity axiom. And because of that, 2 divides y, because we don't want fractions or decimals to be 80. So here we assume y is equal to 2k, where k is a natural number. Now we assume the angle CPD as theta. Then CPB will be obviously 180 minus theta. You can draw a diagram and check that out. And then we just figure out that cos CPD is obviously minus cos CPB, because cos 180 minus theta is equal to minus cos theta. Now all we do is just use cosine rule. Now cos theta, which is cos CPD, is going to be, well, the sum of the squares of the adjacent sides, which are holding that angle basically, minus the square of the opposite side divided by 2 times the product of the adjacent sides. So basically that's what we did here. We simplified it here, and then here we directly substitute y is equal to 2k, so we directly get 4k squared instead of y squared. Better write it this way, so you can just cut down 4, and then this is what we get. Now we just add these two equations, and then we get 0, obviously, because cos theta minus cos theta is 0. So now we just equate the denominator by taking the LCM, and then you get this as your final equation. Now this is pretty easy. Anyone can find positive integer solutions for this, but that's what makes this interesting. Now here we have 4, 2, 1, 3, and 5, 1 as the solutions. Now due to the triangle inequality, we have PC is equal to 2 and PD is equal to 3. So you can't have 1 as your x value, because 3 minus 2 is equal to 1, but x is supposed to be greater than 1 and less than 5, which is their sum. So the only solution which includes all of them is this solution, 4, 2. Now this gives us y is equal to 4, because it's 2 times k, which is 2, so 4. And this also holds true, you can check that for yourself. Then we find the sides in terms of x and y, and then we basically use the formula for cyclic quadrilateral, which is this, root of s minus a to s minus b to s minus c to s minus d. And then here s is the semi-perimeter, which is half the perimeter, so that gives us 11. And then we just find the area just like that. So we get 27.11 at the end. And coming to the tangential part. Now remember we had 4k squared over here. I'm replacing it with y squared again, because we don't really care whether it is 2k or not there. We don't want them to be integers anymore. So this gives you this equation, and then we know that sum of the opposite sides of a tangential quadrilateral are equal, which is a pretty easy proof, to be honest. Then we add up the sides, and then we get this equation. Then, yeah, this is what we get at the end. And then substitute this in this equation. That gives you this, and then you can cancel down 4 over here. So this is what we get at the end, and then we simplify to this. Then we can cancel down 3 here. So we have 25 over here, and then 4 get cancelled here. You have 7 here and 13 here. So 13 goes down, so you just basically have 5 root 13 as the value of x. And then you can easily find the side lengths of everything else that way. And then, well, the radius of a bicentric quadrilateral, or basically cyclic and a tangential quadrilateral, is basically the same formula it is for a triangle, which is the area by the semi-perimeter. So that gives you this formula. And then we just basically substitute the values, everything done, and then we just simplify this to get 2.54. So that's the end radius for a specific case. So these are the answers to our questions today. Hope you enjoyed my video. Do like it and subscribe to my channel for more such videos. And hope you really enjoyed this video. Thank you for watching. Meet you next time. Bye bye.